Hello, welcome to our podcast Stack More Layers. My name is Maria Janicka and I am an AI researcher at Synerise. Today I will be talking with Michał Kuźba, who is machine learning scientist at Expedia Group, but with some impressive experience working in projects for companies as Facebook, Microsoft, or Samsung. Hi, Michał.
Hello. Hey, Maria.
Okay, I'm very glad that we have a chance to talk. And maybe I wanted to start with your previous projects. And because, as I told, this experience of yours, professional career, looks very impressive with such a huge companies there. Uh, so maybe you could tell us something about these projects, maybe about some challenges or things that were especially useful in your further career.
Sure. I'm more than happy. And thank you, Maria. And first of all, excited to be here and share some potentially and hopefully interesting insights from my side. So, yeah, I don't know if it's impressive, but definitely interesting experience in the past that I had. And I cannot recommend enough having internships and experiences in these big companies. For me, it was one thing just to see how they look from inside, right? There is a lot of talking about what Facebook does, what Microsoft does. And, when you see it from inside and you see it's like how big, how massive effort it is, how many people are involved, it's super interesting. And the discussions over the issues they have. So for me, it was super interesting. And I was a student then, and it's really different for what you do at university. It's really a different scale, and the culture is different. It's for example, it's funny how big companies they differ by the culture they have. Like these big American companies, they're really direct, and sometimes, like for example, at Facebook, even as an intern, you can see quite a lot of stuff going on and have a lot of permissions and power to do stuff, to break stuff potentially. So, but it's very empowering to have that. It's super interesting how, for example, they can test their solution. So, for example, like Facebook, they can do very complex A/B testing, which is not just A/B testing, but they can deploy a feature to a subset of users, and they have very well-defined groups, and they can test based on your interests and other like behavioral information, which is simply amazing. And it's quite a big machinery behind that. Their code base is huge, and just searching something in the code base is already challenging. And they have solutions dedicated for that. And so yeah, it's amazing, like the scale they have. Maybe also just like one thing that stuck in my memory is that, for example, Facebook, obviously they have a lot of models to take down bot traffic, and there's some bot accounts, and they need to be super accurate at that, because if you have too much false positive, you start closing real accounts, and the desired accuracy is 99.99 something, right? Because if you're mistaken but just like 1% or even less, then it's millions of accounts. So it's really like the scale is definitely something unique. But for me, it was super interesting learning to understand what I like, what I don't like as well. That's why it's super interesting to try a lot of stuff, and internships are great for that. So I recommend, like, especially if there are any students listening to us, I recommend trying. It doesn't cost much. It's usually pretty short, but you can discover what you like, what you don't like. So, like, one thing I discovered, and that's why I'm in my current company, is that I like working on the data I'm understanding more or less. So that's why I travel data, because I can relate. Like, you need to usually debug a lot of data as a data scientist, right? And
Yes,
that's pretty painful. So if it's a bit
definitely.
more enjoyable, that's always valuable. Yeah. So that's it.
Yeah, great, great. This A/B testing opportunities that you are speaking about, like, sounds amazing because I think that's always an issue when you are creating something and you have this unknown of how it will work
Sure.
in real life. So being able, and sometimes in my career, there were a project that, for example, was ended before they were deployed. So, based on some information from offline tests, so we had never chance to see how it would work live. So I think that's the great opportunity.
Sure, definitely. I think testing is a very important thing, and a lot of machine learning projects they simply fail because of it's complex. You need to test it. You need to wait a lot for the test, and sometimes the test is not trivial thing to do because not always you can do a proper A/B test. For example,
Yeah.
we cannot display different prices to different people, for example. And so well,
Yeah. Yeah, that's interesting point. Yes, and how untrivial it is. It's maybe also indicated by what you said about this measures that in some cases false positive are very expensive, and we want to avoid them at any
sure,
cost. So,
sure,
so you also need to know the cost of your mistake.
exactly.
That's a great outtake. Okay, the other question I wanted to ask, because when I was doing the research for our conversation, and I scanned your LinkedIn profile.
Great job, great research.
Yes, yes, a great part of my research. But yes, and I saw that you were working a lot with graph data
Correct.
in many projects, and what I discovered working with customers, that people not experienced with data science often have issues with seeing graph structure in their data. So maybe you could provide some real life examples of data where there is a graph structure.
Sure, definitely. So yeah, we're trying. It's apparently a hot topic and something new. Like there's new solutions. So we're trying different approaches and the graphs that we have. So there's different types of graph. Like arguably, you can say that every data set is a graph, or you can make it a graph. Maybe it's a bit of clickbait. It's not the case, but like usually, whenever there is some structure, or you can make a structure, that's a graph. But also whenever there is some relation between entities, which is simply some action. So for us to be a bit more specific, for us, we at Expedia we're a travel agency. We have hotels. We have travelers booking those hotels or simply clicking on some hotels, hotel rooms, etc. So like very natural first approach is that you have a graph of users and hotels they book or they click on or they simply see there are some impressions. So the entities in that graph are users, hotels, rooms, and things we basically sell. So kind of products, and the relations. So the edges in that graph might be, for example, whenever a user clicked or booked. So that's a good graph to start with, and that's just one thing. The other is obviously in a big company, you have a lot of products. There are some relationships between them. There is some hierarchy, for example. There is geography involved as well, and every hotel is located somewhere and belongs to some cluster or something. And every time you have those relations, you can define a knowledge graph, which is another graph that you can work with. So yeah, there's a lot of structures like that, and I think it's quite omnipresent and a lot of data, especially on user activity. It's a graph, or you can model it as a graph. That's obviously one of the options, and it's kind of similar to matrices somehow. You can have sequential approaches, but that's the beautiful thing, that you can approach the same problem in multiple scenarios, and it's not only about the algorithms, but how you define your data, how you build your data structure. And it might be pretty much the same, but then for example, matrix is a graph kind of, or like graph is a matrix. But then it unblocks a new way of thinking about these things, and allows you to think of some new methods. It's amazing. And when I was taught, for example, algorithms at university, the subject was called algorithms and data structures. for more classical algorithms, right? But I think for machine learning, it's pretty much the same. Like it's equally important how you represent your data to how you process it, or it's a very important
Uh,
step. So yeah, it's exciting and apparently pretty popular in data science community. So I don't know about like how people perceive it in general, but for us, I think our customers, they are not aware of exactly what methods we use, and that's fine. So yeah, we're experimenting with this a lot.
yeah, it is very interesting, and as you told that, uh, it is a way of framing your data
Correct.
uh, in a way that enables some further processing methods and steps. So I think that a lot of data can be framed as a graph or represented as a graph because we need to have some entities and relation between entities, and in fact that can be stated about a lot of problems or in a lot of domains.
Sure.
So
Yeah, definitely. I was just like a month ago on the conference on the European ECML European Conference in Machine Learning, and I was super surprised to see that I know like 20% of the tracks were kind of graph related. Graph mining, networks, graph neural networks, and things like that. So apparently there is a lot of interest in the research field, but as I can tell you, there is also an interest reflected in the industry, and I think you can see that
yeah,
as well. And
healthy.
yeah, that's an exciting thing to see.
Yes, also here at Sunrise we put
Oh yeah,
a lot of effort and stress on this graph structuring data and how to represent it.
sure.
Yes, so maybe now we can proceed to the present times, and what are you currently working on?
Sure. So my team is called Data Science Pricing Team or Data Science Lodging Pricing Team, and this lodging means that we deal with hotels. And because my company deals with hotels and flights and car rentals and stuff like that, so I'm specifically working on hotels and then the so-called conventional lodgings, which are hotels, and as compared to vacation rentals. So we also have vacation rentals, more like Airbnb style. They're a bit different, also exciting. But we're working on the classical hotels and I'm on the pricing team. And I have several projects. So for example, we are now working on building some representation for some of our products because that's where graphs come into play, kind of. Because when you have some predictive model to train, you need to build representations for the entities you have, and that's where we explore multiple methods to see how we can best represent our products. So I think like what I can tell you, because it's fully published by some colleague of mine, is that we, for example, have an algorithm called Hotel 2Vec, which is a more sequence-based learning, and we build representation for hotels, but we want to build that for other entities we have, and we're exploring multiple methods. So I'm working on that, and because we need to, as I said, like have an input for our whatever model we use, whether it's ranking of properties, whether it's pricing, we want to have a good representations of what we work with. But also we need to compare hotels, for example, to see which are similar, and yeah, there is. So like one thing is that we are traveler facing, so we have people who come to our website, they want to book some hotel, they want to book some flight, but also we have hoteliers, and we need to be able to, for example, provide tools to hoteliers, and they need to know which hotels they should compare to, and for example to set the price, because you want to be similarly priced or better priced than your competition. So there is a lot of things around pricing that we're working as well. So predicting prices, demand, and basically a lot of behavior around pricing and user activity and yeah, things like that.
Yeah, so the what I heard here is that you work a lot of building this representation. So what we were talking about earlier, that we have data and we need to represent it somehow to in a way relevant
Hmm.
for a given task. So maybe can you give some example of some entities in your data, and how do you represent it, or what is I don't know how much you can tell without
Sure, sure.
yeah.
It's always tricky. I like to talk, but don't worry, I will make sure not to say too much. Don't worry, I can ask. So we have definitely as a main entity is a hotel or a vacation rental, and then within that hotels you have hotel rooms, which are also interesting entities because in the end what you book is a hotel room and not just a hotel. And then you have also complementary products such as I don't know, breakfast, dinner. So we aim to be a online travel agency. That's how we are officially called, and basically anything travel related should be possible to book with us. So we have also flights, car rentals, activities, packages, which is combining some of the sub products together. But yeah, I think the major one is hotels. And obviously, on the other hand, you can think of users as your entities in your data that you want to kind of know something about. And for hotels, we obviously have some features naturally, like we know something about them without any trained representation. Like you know the star rating of your hotel. You also know, I don't know, like the review score, and there is the geographical location. So you know something, but it's often not enough. Is usually not enough because one thing is how you compare based on these features. I don't know what is more important. I don't know star rating or the review, or it's difficult to say. Um, so naturally, what you want to have is this like embedding or representation that you can plug into some model, and the model will know what to do with it, or you can apply some similarity measures. So that's definitely something we are working on because we need to understand our inventory. And for example, there are some challenges as for this vacation rental. You don't have a star rating. It's just somebody's private house, and well, it's difficult to say something about it. So whenever we can use travelers' data, we use it. And don't worry, we don't do anything shady. We don't know anything private, to be honest. It's more about like which hotel you as an anonymous user for us you clicked, you watched, you booked, and based on that we can build a lot of intelligence. And because we have quite a good volume of that data, it's super interesting insights because well, we are one of the biggest in the field, and we have a lot of data that we can leverage to build some representations. Obviously, it's not always enough because you have this cold start problem, and then you cannot rely on the past user activity because there is no past user activity. So always interesting challenges to combat, but basically, yeah, a good volume of data from which you can build some traveler-driven representation, let's say, for hotels, for hotel rooms, and so on. Mm.
Okay, so yes, I think that this what for me is interesting, and you somehow mentioned it, that it is hard to decide which features of this given features like ratings and reviews are more important, and it's where AI can help us because it can mine this hidden relations in data,
Exactly.
and that's how it's done by analyzing the history of users, as I understand.
Yeah, definitely. And arguably, what your users tell you is the most important. So if users
Mm.
think something is similar, then it's similar because they think so. And you, in the end, you have, your product is for them. So that's important thing to leverage. Obviously, there is always like some biases because user what user book, what user click on is kind of biased by what you offer, what you rank. Obviously, there's always some bias. We have a ranking
Yeah.
system. What's on the top will be clicked more likely than elsewhere. But I think it's a problem of every like company that has some search, some sales, and that's something. But anyways, like what your traveler, what your user, we call them traveler, what your user thinks is very important to understand.
Yeah, because somehow mapping this hidden structure of user, I don't know, interests or patterns of behavioral patterns is also mapping some I think maybe greater knowledge about product similarities from this pragmatic point of view of a given domain.
Right.
So that's yeah, self explanatory, I think. And maybe I think it was somehow already covered, but maybe to put some emphasis on it. So you create these representations, and what do you? How do you use them? What do you predict based on this representation?
Sure. So there is a lot of downstream tasks that you use it. So well, basically, like loads of models that we use, they do some prediction on hotels, for example. As I said, we predict prices, we predict demand. So like when will be the bigger demand, and someday I don't know, like do people travel on this season, this day to this destination or this hotel or something. um, and then you need to have a hotel as an input, and you have this hotel embedding. It's great. You can do machine learning based on it. And then if you want to, for example, build some cluster of hotels to basically judge for the hoteliers what they should compare to, and how to set their prices, then you use the same representation. So it's very handy that you can build it and then use in multiple tasks. So whatever we predict, we plug this representation in. Also, when we rank hotels, so you search, I don't know, you search Warsaw, you want to go for a weekend in Warsaw, and you have, I don't know, like 1,000 hotels as an option, and then you need to rank them somehow, optimizing a lot of stuff. Then you have this hotel representation handy, and you can plug it to your model. So it's super interesting to have it, and you can reuse it in multiple models.
Yeah, so it's about creating this universal representation that can be utilized to predict many things and enhance many products, as I
Sure.
believe, end
Yeah, yeah,
products.
sure. And obviously, still you have those information that you shouldn't abandon. That the star rating, I don't know, the geographical location is only part of it. And well, sometimes it's interesting if the representation is actually universal, and if you sometimes need a bit of different notion of similarity or like proximity in this vector space, and maybe you train it a bit differently, or you just have a slightly different data, and the data often indicates what you will learn from it. But yeah, it's super useful building block of further modeling.
Yeah. And okay, so now I would like you to ask you about the challenges or some challenges you can have with this type of task or this type of data, because I know that there are also always some challenges with data, and data processing is the painful part
I
of machine learning work. So if you could tell us something about challenges with data, and maybe which of these challenges are more general, so you can meet them with any type of data, and which are some domain specific challenges, because
Sure.
I think it's also interesting.
Sure, it's challenges is there's always loads of them, and data is very surprising. But well, there's a lot. So, for example, one thing that's maybe very specific to our industry, maybe not, is that there was this pandemic, or there is still the pandemic, and it very much
Mm,
affected the travel business, the travel industry. I mean, like 2020, I don't know exactly the numbers, but we were dealing more with cancellations than with transactions, right? So you have a long period which is very different than the past. And usually, like the past was more or less predictable. So the data, some patterns, they were more or less predictable. You have summer in Europe, people travel. You have winter, people travel to maybe ski in Switzerland, but It's quite predictable. It may be growing every year, but slightly. So there were some trends, predictability. Some models were working, and then you have this black swan. You have pandemic, and everything crashes, and like your demand prediction doesn't work anymore. There's no demand, or people start traveling outside of the cities because they have some nature and then balcony and something. So it changed a lot. It was a bit difficult. I joined in the middle of pandemic. It was very interesting to see this happen. Now it's all recovering. But for example, when you use the data from pandemic, you always need to be a bit careful. And when you want to use the data from before pandemic, you can do that, but it's a bit old now and doesn't reflect the latest trends and activity. So it's tricky. That's definitely the thing. And I think definitely for us, because we're in this travel industry, I think everyone was kind of affected. But if it's, I don't know, you're selling stuff on Amazon, maybe people still buy on Amazon because it's online business and there is no physical
Yeah.
activity. Here there is physical activity is a core of the thing. So traveling was banned. Or for example, business travel was recovering a bit slower. So you have a shift in the trend because this segment of travel is gone. So basically, you learn some patterns and they might not work anymore, and you need to be careful. That's definitely one thing. And then we have a lot of activity that we need to track. Sometimes live, real time, sometimes not, and it's very huge challenge to do it properly. And we have teams working on that. So it's not me, but we have like data engineers working on that specifically. But always there is, I don't know, some missing values that it's hard to deal with or hard to explain, and then you don't exactly know what to do with it. I think it's pretty universal to have missing values, right? But
General
how to address them
challenge.
is a challenge because you need to do some educated or less educated guess how to feel or ignore those missing values, and it's always tricky. So that's what I can think about at this moment. And I think also as we are a relatively big company, data discovery is a problem itself. So you have a lot of tables, you track everything, and not always you know where is the data located, and it's more like problem of the company how to share the data. Documenting data is super tricky. We know how to document the code, we don't know how to document the data maybe super well, and how to search through the data you're having. So these are some of the challenges, definitely. And for the graph specifically for the graph problems, or maybe this user activity, as I mentioned briefly, is sometimes you don't have it because you have a new hotel coming, you have some closures, especially after pandemic, but and then the hotels are not there anymore. So there's a shift, but also like you have new hotels, you don't have any traffic on them. You need to predict something based on them, but not based on the past data because there is no past data. So you need to impute some values, and it's always super interesting to see.
Yeah, a lot of interesting challenges you mentioned, and I don't know what to start with because I have a lot of thoughts on it.
Sure.
Because first of all, with this pandemic, it's very interesting because we have some. This is like very visible in the domain
Hmm.
you're working
Okay.
in, and I can imagine that this shift in behavioral patterns of patterns how people uh, interact with with your data, or like the travels were banned,
Yeah.
so it's very hard to create this universal representation we were talking about are no longer valid when in this special situation, but also this created based on this special situation and are not valid later. So this unpredictable events can be very challenging.
Oh yeah, definitely.
in yeah and then I think that this is general, like in the sense that in each domain there can be some unpredicted events that influence people behavior,
Hmm.
and hence they influence the patterns in data.
Sure. For example, for us, yeah, there is a lot of unexpected behaviors all of the time. But this one was very particular because it was global. So, like for example, like recently we closed our offering in countries like Russia and Belarus because of the war, and there is no hotels there. Obviously, that's some change, but this pandemic was global, and the trends were visible everywhere. So it really affects the whole thing. Yeah, it's very difficult to deal with that because it's everywhere. It's not that you can refocus elsewhere. It's just omnipresent, and well.
Yes, very interesting. I'm thinking how to adapt to this situation because before I didn't. I wasn't working in the on the position that required me to somehow thinking about the solution, the adaptation to this pandemic situation with regards to behavioral patterns and data. So yeah, so that's very interesting topic. And also, I found interesting what you said next. So about okay, I got lost.
Don't worry. Don't worry.
Sorry. Okay, let me think because I had this one more interesting.
I'll
Yeah,
drink some water during that time.
yeah, maybe me to the topic that I want to cover because we're talking about this pandemic data, and then you. Yeah, I know. Sorry, I've got it. So yeah, because you were telling about some challenges connected with collecting data in different forms, sources, uh, and I think that this is an issue that we as a data scientist
Hmm.
have this data point of view, but life isn't yet fully data centric. So we see this domains where we are working in from this data point of view, maybe,
Hmm.
and somehow we need to transform the streams that are collected to the form that is somehow usable for us. So that's this this buffer between like reality and how data are collected, uh, and the form that is that can be utilized in machine learning
Yeah,
algorithms. And I
sure.
think that this buffer is
Sure, there is.
is where a lot of challenges are.
Definitely, and well, there is. This is a process, and it's in our company at least there is multiple people working on that, so it's not data scientists or how we call it machine learning scientists, but we have, for example, data engineers who are responsible for data processing, data collection, then like maintenance of the tables and so on. So definitely there is a lot of work there. Um, but yeah, it's interesting you say like it's what we do is pretty how you say like data driven, and they like data is there. Obviously, there's always a problem how to process it, how to expose it to us, model developers in the end, and researchers, and a lot of challenges all the time. But yeah, I mean, there is um, even some of our partners, so the hoteliers, they do some data science probably, like they have some pricing strategy, and sometimes this pricing strategy is pretty complex if you have a big hotel chain, and sometimes it's super simple because it's like a family owned hotel and they just have a different price for maybe summer and winter. But and That's where we are in a good position to try predict, because we aggregate information and they just have their one single hotel, but there are big chains and they do some interesting data analysis definitely as well. And we do analyze a lot of data, so that's yet another position which will be something like analyst. So you just need to understand like what are the differences between you and competition, or differences between hotels, and like what is driving it. And there is a lot of dashboards and processing of data and analytics. So this is a process, and I sometimes feel like the machine learning is at the top of the pyramid, that you need a lot of people to work for you, to provide you like, it's not only data, because in the end there is some back and front end, there is a website in our case, but there
Mhm.
is there is data engineering, they provide us data. There is machine learning engineers, they um, deploy solutions, they productionize, they monitor. There is analytics providing insights and working on data as well. And we are in the top, trying to kind of, not at the top because we're best, it's the top because we require people to help, and we're just very specific in things, and we need to kind of optimize the processes. So we build on work of a lot of people, definitely.
Yes, it is also very interesting how this work is divided, because we often say, okay, data science, machine learning, but as you said, there is a lot of work done by different teams that is required to have this final solution, or to train this machine learning model, or to create this representation. So in order to create this representation, you need to have some good quality of data that is collected from some huge data streams, and this is a challenge for a whole another team, as I understood.
Oh yeah, definitely. So it's always pretty confusing, at least the way I see it, that you when you see some job offering, some position, and it says something machine learning, data science related, you never really know what it's exactly about, because there's no like officially established titles. You can be machine learning engineer, and like in our company, you will be productionizing things. But sometimes machine learning engineer is someone doing research and developing models. But well, it's quite confusing, or sometimes to navigate it. I think it's getting better and better, but definitely it shows that there is a lot of positions within machine learning that is addressing slightly different problems, or really different problems, and different parts of the pipeline. Uh, yes, of the model and modeling in general.
Yeah, it is very very interesting for me, because and I think also that from our Sunrise point of view, because we are thinking how to make some parts of this, how to automate some
Mm.
parts of this pipeline, to be able to have only like to make it easier to experiment and to do this creative job. So yeah, so that's always interesting for me, uh, how uh, how many different skills and how the job is divided, and what needs to be done, and what can be automated. Yeah, but this that's interesting. Okay, but I wanted to ask you also about your uh, academic research, because, as I saw, you have experience in academic research at Warsaw University, and you co-authored many papers on the topic of explainable and interpretable machine learning. So maybe you could tell me something about this research, and where this need for interpretability arises, and how you how you were dealing with this issue.
Sure, it's yeah, another exciting topic. Was working for like around 3 years in the lab called MI Square, which is based in Warsaw University of Technology and spanning also University of Warsaw. Um, so it's exciting things they're doing here. I recommend to check it out, definitely. But the field is super interesting, because we build a lot of models. There is a lot of intelligence here and there, and it affects people. It's great that it affects people when positive, and when controlled. But sometimes you don't really know what's happening, and there is a lot of these famous failures of machine learning models that they predict something, but if you dive deeper, then they, like this famous predicting wolf on the picture because there is snow in the background and not that there is an animal in the
Yeah.
first place. And then when you think about some high stake decision like, I don't know, healthcare, if your model is, I don't know, predicting cancer because of some parameters of the machine and not actually the image itself, then it's super worrying. Um, and we don't know how, for example, neural networks, what they really do. I mean, we can analyze the matrix number by number. It doesn't tell us much. So it's really important for multiple reasons, depending on what use case you have. Sometimes it might be regulatory. That's, I don't know, in finance, you need to kind of explain what your model is doing if they're not biasing people against certain things. Another famous example is this model in US that's trying to predict if you will commit a crime again, and it's really based on things it shouldn't be based on. It's in some characteristics of people based on bias against their race and so on. Um, and it's super tricky, like the screening of resumes for Amazon for hiring, and it's detecting the gender really easily. And when you think about it, like, you can remove a gender as a feature, it's still there. It's correlated with so many things, and you need to actively try to remove the bias and not just, pretend that it's not there, or just remove the feature indicating it directly. So it's an interesting challenge, and there is a lot of work to do there. So I was working on firstly on some visualization tool, and then I was working on conversational explanations. That was the major topic, and it was super exciting because arguably, like, if you want to explain something to a human, and it's us who are addressees of the explanations, then if you want to explain something to a human being, we use a language and we ask questions. So if you can provide an answer in natural language, is super good, especially if you're not technical. So
Mhm.
if you, I don't know, interact with model of a bank, and you were rejected for your credit application, you're not interested in feature importances or some charts. You're interested in maybe in asking a question as you would ask a normal regular person working there. So it's super interesting. And then the third topic, which is an ongoing work, I'm not there, but it's an ongoing work, is analyzing the regulations of AI and policy documents. It's
Mhm.
something people are trying, I don't know, in European Union on the national level, trying to understand how to build some regulations. And regulation is always behind the innovation. Um,
Mhm.
and on one hand, you want to, regulate it to prevent some abuse, but you don't want to destroy the innovation as much. And yeah, it's super challenging to analyze how it's evolving and where it's going. So it's a lot of interesting stuff, but also now I'm more in the industry. It's super interesting to see that it's getting more and more acknowledged that there is something like interpretability, and you might actually care to think about it, to use it. Even some of the toolkits like Shapley values, they will be considered as kind of a toolkit of a data scientist, that you no longer need to explain what it is. You can say, I'm using Shap, and this is what I get, and this will drive some insights either for further modeling, or maybe for like informing your I don't know, like managers, or like people in the high management of the company. They sometimes want to understand, okay, you have this model, what is it based on, and what does it do in this scenario, and so on. But yeah, so this interpretability is something huge and growing. So it's interesting to see it, and sometimes we also want to use it as part of the solution, and explainability is considered a good advantage, or sometimes a must. And especially like when we want to say to our, say, hotelier, do some action here, it will help you. You need to provide these actionable insights, and then provide some explanation, like why would I do it? Why would I change, I don't know, my price? What would that change, and by how much, and things like that. Um, so that's definitely interesting. But there's a lot of black boxes here and there, and you could even argue
Mhm.
that simple systems are more black boxes than we think. I mean, it doesn't need to be a neural network. If you have a score. So if you have a review score, it's maybe interpretable, fairly simple. I have an average of scores people give. But if you build a score of a hotel, how good it is, like some numerical score, and it's based on something, and it's not very clear based on what it is, then it's super tricky. Like people will be, okay, why do I have a low score? How do I improve it? Like, you always
Right.
need to have a way to improve it, right? Uh, and then you need to provide some more insights. But yeah, it's a super exciting field, and the way why I like it is because it touches both modeling, AI, and people. So it's a nice intersection.
Yeah, because interpretable AI is like beneficial for people who could understand this decision of a model, but also for developers and even in the industry, because if you know why the model is making some decision, you can improve.
Definitely.
And you know, these biases are also sometimes like an issue
Mhm.
for the company, because it's this popular examples are something that can be like socially harmful, let's say, but there is also some model mistakes that can be that are that will be very beneficial to be able to avoid while developing a model, because so I think this is both like very needed research on this social academic level, and very useful on this also like everyday life
Definitely.
of a data scientist.
Definitely.
Pragmatics.
Definitely. And I think we are kind of there. So like you have tools that you can use as a model developer, as a data scientist. So there's like Shapley values, there's Lime, there's Dalek, there's a lot of toolkits for fairness, for interpretability that we can use, and where obviously it's just probably just the beginning of a journey, and it's acknowledged. People use it. It helps. It really does. But then another interesting thing is how you communicate it to someone non-technical, and obviously there's a lot of interesting discussions there if this interpretability is actually something great, and how much you can explain what model is doing, because if you have a neural networks, they are complex. You cannot explain them by a simple decision tree because there are no decision tree, and or you cannot explain by two rules or like two feature importances because they are big. There are neural networks. Otherwise, you would use a simple model, but simple models do not work sometimes. So it's difficult. Or how you explain a representation, like we're talking about. How you explain a graph, something was built from a graph. I mean, it's all difficult, and obviously there is maybe luckily not always a need for explanation, um, because sometimes, well, if your model is ranking hotels, maybe sometimes we need to explain what is going on for the traveler perspective, but not always. Or maybe, well, sometimes there is like people life is affected, then you really need to, but sometimes you just optimize certain processes and see if you're doing better or worse, and nobody's life is affected, so you need it a bit less, but maybe you still need it to understand your model and improve it. So yeah,
Yeah,
maybe it is.
but also I think that in like human decision making, there are also some heuristic that we are as a decision makers that we are unaware of. We often, I think that we may say that there is a part of decision making that is that we are not aware of, that there are some our heuristics, because we do not analyze every little detail but our when making a decision, but we like just do it maybe based on our experience, and with time we are shortening some paths, and
Yeah,
there are
that's
some
exactly,
yeah
that's the trick. we
hidden
don't
assumptions.
we don't know how our brains work too much, so we don't know. And you can
Yeah.
sometimes make some I guess I think fake explanations that if I if I'm asked how I recognize that, I don't know, what I see is an apple. I mean, I can tell some story about it. Like it's an apple because it's like red and then or a circle shape, and you know, but it's probably not how my brain recognized this as an apple. I don't know how it recognized it. Maybe it's compared pixel by pixel. I don't know. Probably not. I don't really know. I just recognize it based on some experience, based on some past information, because I was told that this is how an apple looks like when I was very little, but I don't know. So it's yeah, it's very interesting that we have some certain requirements from machine learning models to be
Yeah.
interpretable. We don't have them from a human perspective, but yeah, we can argue that maybe sometimes we are predictable. If humans are predictable is a tricky subject, right? But like when you have this autonomous driving cars, well, it's always argued that people also make accidents quite a lot, and why would you have higher expectations? But we already know how we drive for quite some time, and we know what to expect. And sometimes a machine learning model can make very embarrassing mistakes
Yeah.
while being super performant elsewhere. But sometimes they still do very embarrassing mistakes because they, I don't know, never seen something in their training data.
Yes, and I think the other thing is that people are not engineered by us, and the models are engineered by us. So we feel somehow responsible to understand them better than maybe we understand
Yes,
ourselves. It can be also this concept, yeah. Because when I was thinking about this decision making, often we also have some emotions included in the process. So we are making some decision and based on in an affect, for example, and then when we are explaining why we did it, the explanation have nothing to do with the real reason.
sure,
So this I think this interpretability we are doing on ourselves is also not always the best, but we are not responsible for how we are engineered, and we are responsible for how the AI is engineered.
definitely.
So I think that's the difference. Okay, it was very interesting and valuable discussion. I'm very happy you shared your experience and your knowledge, and yeah, it was very interesting for me, and for sure there will be a lot of to think about. Uh,
My pleasure. Thank you for the invitation. It was really great talking with you, Maria. I'm super happy. Yes, thank you.
Great, thank you very much, and I'm happy you joined us, and maybe we'll have a chance to meet again in some time.
Sure, I hope so.
Great, so thank you. Bye.